The topics that are covered in grade 11 and 12, it's your statistics, your analytical geometry, your trigonometry, and your Euclidean geometry. Next slide, please. Then out of the 4 topics that you're supposed to do, here is the difference between grade 11 and grade 12. The content that is in grade 11 is not different. This is what I said previously. It's not different from the content that is in grade 12. In fact, 70% of the work in grade 12 is from grade 11. Statistics in grade 12. What is something new that is added in statistics? It's the regression line, the correlation function, measuring the reliability of the data. And then we've got analytical geometry. We add question number 4 of analytical geometry in grade 12, whereby we're doing a circle. We're doing a circle, relationship between a line and a circle, relationship between 2 circles, as well as the tangent in a circle. And then we get to trigonometry. Trigonometry, the only thing that is added there is compound and double angles, your maximum and your minimum values in trig function. It's a 2D in grade 11, and then in grade 12 we now say it's a 3D with horizontal planes. Then you've got geometry in grade 12, which is to add similarity and prop theorem, which is probably about plus minus 20 marks, and the rest is grade 11's work. So we can get to the next slide. So one thing that I did here is that what is it that is needed from you as you are getting to your exam when it comes to paper 2. Before you go to your exam, you need to set yourself goals. That's the first thing. And when we're talking about goals, we are referring to goals that you can achieve. Umpila mentioned a lot of things on the topics or the things that I've actually written about here, and said something about reviewing your work. Reviewing your work means that if ever you got your 95%, that's what she said. If you got your 95%, always go back and check, how did I lose this 5%? A lot of people tend to believe that if ever I got a 10 instead of getting a 20, it means that I did well. But there is one thing that they do not do, is to do a reflection. What is it that I missed in this 10 marks that I've lost? So that you now understand how to get the 10 marks that you actually got. So the question now is, how am I supposed to get the remaining 10 marks so that I'll be able to master this topic? The stats is 20 marks. The analytical geometry is 40 marks. The trigonometry is 50. It's a lot of marks when it comes to trigonometry. And then Euclidean geometry is 40 marks. Next slide, please. Euclidean geometry is 40 marks. I just did a comparison now on questions. On the following slides, you will just see the comparison of questions. In grade 11, if you look at what is in front of you right now, this is a November 2022 paper for grade 12. If you can see the question, it has got a table with learner's marks, SBA, and final marks. Let us look at the questions that are being asked. They said, determine the equation of the least regression line. You don't see that kind of a question in grade 11. It is a question that you only get to see in grade 12. So this is either going to be your question 1 or it is going to be your question 2. The second question says, determine the correlation coefficient. This is also something that you won't find in grade 11, but you will find in grade 12. Please get to the next slide, please. And question 1 in grade 11. I don't know what happened now. Because I want us to see the difference so that we can get to the part on how to.
Yes, apologies. It kicked me out for a few seconds. Let me share again.
Not a problem. We just want to check right now the differences, because if we're able to do the differences, it simply means that we'll be able to attend to the mastering skill. Grade 12, as you have seen, the statistics has got the correlation coefficient, has got the least regression line, and then we now get to grade 11. If you see grade 11, this is something that you are familiar with, the cumulative frequency table. It's something that you did even in grade 10. So if ever we're talking about the cumulative frequency table, it simply means that this is a chapter that you will also find in grade 12. So as a grade 12 person, it simply means that what you did in grade 11, you must not discard the information as we progress with whatever it is that we have learned in the previous grade to the next grade. So this is a question that I extracted from a paper in grade 12, but it relates with the grade 11. So I was like, let me use this question, because as a grade 12 person, you need to understand that the cumulative frequency that you did in grade 11 will still be applicable in grade 12. The scatter plot that you did in grade 11 will still be applicable in grade 12. So grade 12 and grade 11, they are best friends when it comes to the information. Can we get to the next slide, please? We're just comparing questions now. Then this is your analytical geometry. This is your analytical geometry for grade 11. The same analytical geometry that you have in grade 11 is the same analytical geometry you're going to see in grade 12, which is going to be your question number 3. Your question 3 in grade 12 will be your analytical geometry that is from grade 11. We asked about the gradient. We asked about the angles of inclination, what to determine the values of theta, and everything like that. So the thing that is taught in grade 11, it is not taught in grade 12. So if ever you have learned it perfectly in grade 11, it means that you're going to master it in grade 12. Can we get to the next slide, please? And then once again, this is one for grade 11. It's your analytical geometry for grade 11. It's still the same thing that was asked in the previous question. Next slide, please. Then we now get to the question that is found in grade 12. This is going to be your question number 4. This is going to be your question number 4 in grade 12, whereby we are discussing the circle. It's analytical geometry of the circle centered at the origin or not centered at the origin. So whenever we get to this question, it simply means that you are now in grade 12, which is your question number 4. You will not find it in grade 11. It is only in grade 12. So we are just comparing the differences now between grade 11 and grade 12, so that you are able to proceed swiftly with how do we master these questions at the end. Next slide, please. Trigonometry. Both the two slides that have just appeared here, they are showing the same thing. Your question number 3 in grade 11 will be the same as the next slide, which is in grade 12. But the only thing that is different now with with trigonometry that is in grade 12, they only add the double angles as well as the compound angles. Otherwise, everything else is still the same. It is said here, if 12 times beta minus 5 is equal to 0, and your beta is between 90 and 360, you will encounter the very same question in grade 12 in 5.1. And then it says that if sine 42 is equal to P, you will encounter the same question in grade 12 after 5.1. Then we're doing reduction. The only thing that is different now is that in grade 12, you've got double angles, whereby we now have to change sine 2 theta or cos 2 theta into all the appropriate expansions that we get to have when we are simplifying our double angles and when we are expanding or reducing show that square root 13 sine x plus 3 is equal to 0. It's the same thing that you were doing in grade 11 for this question. It's the same thing. You just have to solve for sine x and make it the subject of the formula and find the answers as you go on about answering your questions. If you look at that 5.1.1, it says sine 360 plus x. Whenever you get to have something like that, it means that you need to reduce that 3 ratio. It's 360 plus x, so 360 plus, you know that it is in your first quadrant. So in your first quadrant, everything is positive. Then you simplify it. Then you've got your cos 180 plus x. You know that is your third quadrant. 180 plus is in the third quadrant and cos is negative there. So if you look at this question, it is exactly the same question that you get to have in grade 11. So there is a great link between someone doing grade 11 and someone doing grade 12. They are actually doing things that are the same. So let's get to the next slide. This must be Euclidean geometry. Or yes, 3D and the 2D. If you look at the diagram that is on your left, we have a diagram on the left that is from grade 11. In grade 11, we're talking about, in grade 11, we are discussing the 2Ds. Are you saying something?
Oh, sorry, apologies.
Okay, no problem. So in the diagram that is on your left, you have got a diagram from grade 11. And the diagram that is on your right, you have got a diagram that is from grade 12. If you can see these two diagrams, there is nothing much that is different between them. Instead, the diagram on your right has been made to be a 3D with the horizontal plane. So the only thing that is added in grade 12, in which we are still using our course, what you call this thing, our area rule. Everything else is still the same, is that the horizontal plane is perpendicular to your vertical line. The horizontal plane is perpendicular to your vertical line. So you now get to have a Pythagoras theorem that must be used because you have the right angled triangle. Number two, you now to simplify whatever it is that has been expected of you. Otherwise, the 3D in grade 12 and the 2D in grade 11, you are still required to use the same procedures that you were using to find the answers. Can we get to the next slide, please? Euclidean geometry. This one is from grade 12. Euclidean geometry is from grade 12 because we get to see that question that is in 10.2, whereby it says show that AD over AR is equal to AS over AC. The minute you get to see size in proportion, size in proportion comes from prop theorem that is taught in grade 12. Size and proportion comes from similarity that is taught in grade 12. So those are the two things that we need to understand at all times. That if ever you get to be in grade 12 and analyze diagrams in grade 12, you need to know that whenever you get to grade 12, there are two theorems that are introduced to you, which is the proportionality as well as the similarity theorem. Can we get to the next slide, please? Yes, we have now geometry in grade 11 and geometry in grade 12. These are the two questions from two different grades, but they are asked in both those grades, both of these questions. If you look at the question on your left, it says that in the diagram below, ADF is a tangent to the circle, with points E, B, C, and D on the circumference of the circle. AB is parallel to DC, and EC is equal to DC. The questions that they are asking in this 8.2 are the very same questions that they will be asking you in grade 12. It's the same thing. It is not taught in grade 12, but it is actually assessed in grade 12. So the diagram that is on your right is a diagram that we find in grade 12 question paper. So the question paper that we use here are different question papers, but as different as they are, these questions are asked in both grades and they are actually the same. Can you get to the next slide? How to master this topic? We have now seen the difference between the two questions. We have now seen the difference between the two classes. So now it's all about mastering. First things first, there is not one way of getting to a correct answer when it comes to Euclidean geometry and trigonometry. I've just written a few things down, but I will mention some of the things that I did not write here. There is not one way of getting to the correct answer. We can use different methods. We can use different methods, different strategies in terms of us trying to find the correct answer. What is important that we must remember all the time, you are correct. That's one thing you need to know. You are correct as long as the procedure is mathematical. That's the first thing. You are correct up until Bodman says this is not it. So first thing we need to understand is that grade 12, do not discard your grade 11 question papers. So if ever you are doing grade 12, I encourage you today that you start piling up on the grade 11 question papers so that you are able to use them to practice. If you can master 70% of the work that is from grade 11, it simply means that the 30% that is introduced to you in grade 12 is not going to give you a problem. Number two, you need to remember that if you have got study sessions or you've got study groups, find yourself a person that is literally doing grade 11 to join your sessions or to join them when they are doing their sessions, so that everything that you have actually forgotten on how it is that you're supposed to do this particular thing, you are then reminded. That is very important. So whenever you are joining study groups, do have someone from grade 11 that is going to be there so that you are able to practice with them. As much as you are not doing grade 11, but you just need them to remind you on how other things were done. And probably now that they are doing it them for this year, it has been actually explained quite better than when you were doing it. Number two, grade 11. What you learned in grade 10 about your mean, your mode, your median, your IQR, and your box and whisker diagram is actually essential, because in grade 11, we will not be teaching you how to draw a box and whisker diagram, but we will be expecting you to interpret a box and whisker diagram with the information that you have learned from grade 10. So those question papers that you actually used in grade 10, sometimes just go back and do revise them so that you are able to understand everything better. And number two, grade 11, when it comes to Euclidean geometry, in grade 10, you were doing Euclidean geometry whereby you were proving that it's a parallelogram. You were proving that it's a rhombus. You were proving that it's a square. That information that you used to prove that it's a parallelogram, it's a square, and all of that, you actually need that information when we are simplifying writers in grade 11. Because if ever you are to prove that two lines are parallel, you are to use the information on how did I prove that a parallelogram has got opposite sides that are parallel to each other, or the diagonals bisect each other. The information that you actually used to prove those theorems is now needed in grade 11 so that you are able to master this thing. The analytical geometry that you did in grade 10 had no angles of inclination, had no equation of a line. But what is it that you learned in grade 10 for analytical geometry? You learned that when you are to prove that it is a quadrilateral, what is it that is expected of you? That information that you used there in grade 10 is actually going to assist you in grade 11. So we're talking about progression here, ladies and gentlemen. So to master this thing, whatever it is that you have been taught in the previous grade, it is direly needed in the grade that you are currently in at the moment. The next one, it says that it is important to ask this question: how is it different from last year? Building on existing information makes you brilliant. So don't start from scratch, because the only person that gets to start from scratch is a learner that is doing grade 0. So someone in grade R is building from nothing. That person still needs to be taught how to write, how to draw, and how to do all those things. But as someone who has a previous grade to reflect to, it simply means that build on the information that you have from the previous grade. How did I get here? How is it different from what I did from the previous year? Because the minute you're able to ask yourself that question, it simply means that whatever it is I am going to say to you now, you are making an addition. You are making an addition on something that I said last year, and you are adding information on top of the other. The minute you have put that kind of a situation going, it simply means that you will be able to understand what is it that you are doing this year, because you did a reflection on what is it that you did the previous year compared to what you are doing at this particular moment. Can we get to the next slide, please? How to master paper 2. Ompile mentioned this thing of low-hanging fruits. I was listening quite attentively to what she was saying. We say that is the low-hanging fruit that every learner must get. So why do we say that is the low-hanging fruit? Because some of you have been doing statistics since grade 9. You have been determining the mean. You have been determining the mode. You have been calculating the standard deviation in grade 11. So the standard deviation that you're calculating in grade 11 is new to you. But then the standard deviation in grade 12 is not something that so you need to understand that. So, sorry, one of the questions that are there for us all is the statistics. Statistics is simple. Hence, it is 10% of the paper. Statistics is simple, and your regression line. I haven't gone into that part yet. So we'll do later. It's all in your calculus. There is nothing that is expected of you, and then all the answers will come out. So if you remember in grade 11, the standard deviation, we used to punch our data into our calculators, and the standard deviation will be there. We punch our data in our calculators, we get the mean. So even here in grade 12, you are still doing the same thing. Hence, we are saying they are low-hanging fruits. It does not require you to think too much. So if ever anything can be done from a calculator and you're able to score yourself 20 marks, it simply means that that is a giveaway question, because part of the questions of statistics, you will be required to use your common sense. When you are looking at this diagram, when you're looking at this Swiss box diagram, is it skewed to the left or is it skewed to the right? And then you get to interpret that. If it's skewed to the left, what does it mean? So it's you now that get to answer that question from whatever it is that you are seeing to analytical. Analytical geometry has got angles of inclination. That the angles of inclination requires a gradient. So if ever an angle of inclination requires a gradient, it means two things. Either there is going to be a line that is parallel to this line where you are to calculate the angle of inclination. The minute there is that information, you need to understand that what is it that is happening when two lines are parallel? What are the gradients when two lines are perpendicular to each other? Number two, the ends that need to happen to learners when it comes to this Okay, I don't know what happened there. I don't know what happened there. Okay, can everybody hear me now?
Can you see the screen?
Am I audible? Am I audible?
Yes, you're audible. You're buffering, but just keep going. Yeah, but we can see the screen.
Let's get to the analytical geometry. We said on the analytical geometry, it's the angles of inclination. You need to understand that the angle of inclination requires a gradient. So gradient, you can be required to calculate the gradient, or gradient, you can be required to use information that has been given so that you are able to say that this angle is, or this line is parallel to this line. Therefore, their gradients are equal. Or this line is perpendicular to this line. Therefore, their gradients, the product of their gradients is equal to -1. Sometimes you will be given an equation of a line and be told that line y is equal to 2x plus 3 is parallel to this particular line that you're actually looking for. So whenever you've got an equation of a line, you must remember at all times that once I have an equation of a line, it simply means that I do have the gradient of that particular line. Hence, the standard form of a straight line is y is equal to mx plus c. Let's do trigonometry. They say that trigonometry and Euclidean geometry need an out-of-the-box thinker. Hence, I said at first, there is no one way of getting to the answer when it comes to trigonometry and Euclidean geometry. How you go on about doing your calculations could be totally different from how someone else goes on about doing their calculations. But what is important is, as we are getting to the final answer, our answers should be the same. And as we get to the final answer, it simply means that the methods that you have used to calculate are still mathematically accepted, because some people just write reasons just because they feel like this is a proper reason. We have our certain reasons that are accepted when it comes to Euclidean geometry. Can we get to the previous slide, people? I don't think we've finished there.
Sorry, Sis Luleka, just so you are aware, you have about 12 minutes with this group.
I'm almost done. I'm almost done.
All right, perfect.
Work out. So it says here, trigonometry and Euclidean geometry need an out-of-the-box thinker. There is no one way of getting a correct answer, but as long as mathematical procedures have been used and Bodimas approves. Number 3, it says that when you're in grade 12,
it says here when you in grade 12, once you see double angles, we've spoken about that once you see double angles, you just change them. Whenever you get to do that, it means that you are going to score yourself a mark. So even if you have no idea why are you changing those double angles, the minute you just change your sine 2 theta or your cos 2 theta, you get to have marks. Then it says in grade 10, your coordinates on the Cartesian plane. You need to know your coordinates on the Cartesian plane because your marks are there. What does this mean when they say that you need to know your coordinates on the Cartesian plane? Because there is one thing that learners tend to forget, that if we are in quadrant number 1, In quadrant number 1, you have got your positive x and your positive y. In quadrant number 2, you have got your negative x and your positive y. In quadrant number 3, you've got both x and y negative. And in quadrant number 4, you've got now your x as positive and your y negative. The minute you get to mismatch that, which is going to affect you in trigonometry of 5.1.1, it means that it's going to be a problem. So you need to understand your Cartesian plane and the coordinates that actually follow when you are doing your trigonometry in 5.1. Can we get to the next slide, put? We are almost there. Then it says in Euclidean geometry, you cannot move without reading the statement. Ladies and gentlemen, the emphasis is always placed here. You cannot answer anything in Euclidean geometry if you haven't read the statement. So the minute you see the word diameter, you need to understand that there is a theorem that is needed, or there is a theorem that is used by the diameter, whereby we say that an angle that is subtended by the diameter is 90 degrees. Moving on from that, if you are told that lines are parallel, you need to understand that in parallel lines,
even if you're not in grade 8, can you answer that? Who can give us an answer as to whether is 3 a common factor to 18, 30, and 48?
On that statement, go and find it in your diagram. When they start talking about the center, I had a session today whereby learners now, they assume that there is a center of the circle. And I was like, the minute you start assuming, it means that this is dangerous. Whatever it is that you are doing is now dangerous. Not everything seems to be what it looks like. We need to understand that. So as long as the statement hasn't said that there is a center of a circle, you are not supposed to assume that there is a center. So because when you see the word center, you need to understand that, oh, I've got radius. So what happens when I've got radius? It means that I've got angles that are opposite equal sides. When you see the word center, you need to understand that, oh, I've got the angle at center theorem. Number 3, the last one, it says, all this statement, once interpreted correctly on the diagram, it makes it magical answering the questions. It's one of my favorite topics when it comes to Euclidean geometry, because there is no way that you could write something without having a reason for it. So whatever it is that you have written, you need to have a reason as to why did I write this particular thing. So now, geometry, for you to be able to master it, it starts from grade 8. When we were doing the lines, your angles in a straight line, they add up to 180. Complementary angles are equal to 90 degrees. So that information takes you here. Number 2, you cannot say that it's an exterior angle, either to a triangle or to a cyclic quad. If ever you have been told that the line has been produced, the line has been produced. If a line has been produced, it simply means that you need to say that there is an exterior angle of a triangle, because you have been told that a line has been produced. So all this information that you have gathered means that it's taking you to the final answer. The last thing that I want to say when it comes to this geometry, there is a situation whereby Elena will be told in 8.3 that this is a cyclic quad. And then Elena is asked a question in 8.1 to determine angles that are equal. And then Elena will be able to say, in 8.1, the angles are equal because they are in the same segment. Whereas in 8.1, we do not have the information that it is a cyclic quad. So you are not allowed, we penalize you when you use questions that are after to answer a question that is before. So you cannot work backwards We only working forward all the time. As much as you have been asked in 8.3 that proved that it's a cyclic quad, you cannot use the properties of a cyclic quad in 8.1 to answer the question that will be using the same concyclic points that you have been asked about in 8.3. Can we get to the next slide, please? We are almost there. Lastly, do not focus on difficult questions. We say this all the time. Your brain is so powerful. The minute you start with questions that you know, you are increasing your chances of understanding even the questions that you wouldn't be able to understand, because your brain has now excreted the juices that you were able to think, and now you are feeling smarter. The more you feel smarter, the more you are able to answer questions. Hence, we always say that the question paper, when you are answering it, it doesn't have to be in the sequence of the question paper. So you can simply start with the 8.1 as your first question, You just start answering by answering 8.1 and identifying that the angle at the center is 2 times the angle at the circumference. The more you are able to answer questions, the more you will be able to answer more questions. So start with what you know and do not focus on difficult questions.
Ms. Nobetsiki,
When practicing,
there's 90 seconds in the session left, please.
okay, it's a wrap
Thank
up. It's a
you.
wrap up, Oz. When practicing, don't focus on the memorandum. Memorandum has been written by a person and that person is going to make a mistake. I always say that. Memorandum is written by someone and that someone is going to make a mistake. And if ever when you are practicing, you use a question paper and a memorandum to check if you understand, it simply means that you're going to be in trouble when the memo has an error. So go to the memo as a reference. Confidence. You must have confidence in your answers. You must have confidence in whatever it is that you are doing. So as you are answering your questions, you need to tell yourself that I've used all the mathematical procedures. So it simply means that I am correct. If I am not correct, where am I wrong? If it's not perfect, it means that you did not practice. Hence, we always say practice makes perfect. And lastly, this paper is for the engineers, ladies and gentlemen, your doctors and your scientists. We are here to prove theorems. We are here to prove that left-hand side is equal to the right-hand side, and everything else is history. It's easy to pass if ever you have the confidence, if ever you have the attitude, then everything else will move swiftly. Thank you so much, Oza. Butluvuko, I believe that is it for me for the grade 11s and the grade 12s.